Hi everyone, so please on your own try question example 5.3 by following the same concept I follow in problem example 2. So you have to apply which formula are you going to apply? Which formula are you going to apply for this problem? You're going to apply this main formula which I have. So we are talking about is an isothermal compression process, and this is the explanation, this is the theory for isothermal compression process. So you have to apply this formula. This is the formula you have to apply for the Banjo work done. Is actually so in this formula you're going to apply the Banjo work done for isothermal compression is going to be P1 V1 ln V2 over V1. So this is the pressure, this is the volume, this is the volume 1, volume 2, volume 1. So that's the formula. It is not specific volume, it is volume. So that is a formula for isothermal compression for an ideal gas. So this is the formula for the Banjo work done for isothermal compression. So solve that problem and tell me if it is an expansion or compression process. So let's look at the next problem which I want us to do. Expansion of a gas against a spring. So we have to use the following step as explained. Step 1, we have to read the problem carefully. We are told a piston cylinder device contains this volume. Contain this volume of gas initially at a given pressure. So this is actually volume of gas. This is pressure at 0.1, and this at that state there is a linear spring that has a spring constant. So this is the value for what? For K, which is what? The spring constant. We are told that what happened now, heat is transferred to the gas, causing the piston to rise and compress the spring onto the volume inside the cylinder double. So there was a given time which the volume was double. So you must see that at a later stage in the system, we actually saw that V2 was equal to a 2 V1. So this is volume, this is volume 1, this is volume 2. So I don't want you to get confused that it is specific volume, it is volume. So we are told that if the cross-section area of the piston is, this is the area of the piston. So now area for the piston is equal to what? 0.25 meters square. We need to determine the final pressure inside the cylinder. So A, so A determine the final pressure inside the cylinder. So before we solve this kind of problem, the first thing I want you to know is that you have to read the problem carefully, and we have to follow our step. Step 1, read the problem carefully. Step 2, get the relevant data. And these are the data which I got. These are the data which I got from the problem. Step 3 and step 2 can be switched. Step 3 and step 2 can be switched. Is we have to identify the kind of problem. Like I said, which kind of problem are we talking about? Expansion of gas against a spring. That's the kind of problem. Even if you are not given this subtitle as it is, you can see that I have a spring, I have a gas that is initially at the temperature. So you could see that I have a spring and a gas. So indicator. So you have indicator to identify a spring and gas. These are the two indicators. These are the two indicators for you to choose that the problem is a spring and a gas. You must have a spring and a gas that is undergoing a process. So now, step 4, which is very important. Step 4, you choose the correct formula based, let me write so you can clearly see my writing well. Based on the question. Based on the given question. And what is the given question? A, the final pressure inside the cylinder. So A, final pressure inside the cylinder. And what is that pressure? How can we establish the relationship between the pressure and the data you have on the question? Those are the common sense questions you need to ask yourself. How can I solve for that pressure based on the data? When I talk of data, based on the data, area, volume, spring constant, pressure, (200 kilopascal). How can I solve for that pressure? I go to statics. We saw that pressure was equal to what? Force per unit area. We saw that it was equal to what? Force per unit area. And now the next thing you must ask yourself, how can I solve for that force? And how can I solve for that area? I know for sure that this area is equal to what? 0.25 meters square. And how can I solve for that force? How can I solve for that force? You must force must be solved based on the equation data. So we have what? We have spring constant K, and we have what? Displacement, which is what? X. Therefore, we can say that the force is equal to what? Is equal to Kx. So this is the spring constant and this is the displacement. So the spring constant, we know that it is equal to what? It's equal to, look at K value on the question. It is given as what? 150 kilonewton per meter. It is 150 kilonewton per meter. We have to what? We have to do what? We have to solve for the displacement x. How do I solve for the displacement? I use the formula for distance. X is equal to what? Change in velocity. Or I call it, but when I talk about volume, I can say change of volume. Change of volume over what? Over area. And that becomes what? That becomes dV over area. That is actually how we can determine the displacement. And that displacement, that becomes what? Is that x which we're talking about, which is, this become what? V2 minus V1 over what? Area. And what is V2? What is V2? What is V2? Remember, V2 equals to what? 2 V1, because the volume of because the volume became twice at that point, and therefore volume at point 2 is equal to what? 2 V1, and that V2 become what? Become 2 times, what is V1? V1 is 0.05 cubic meter, and that will give us what? 0.1 cube. And therefore we can now come to this formula. We say that displacement now become what? 0.1 minus V1. V1 was given as 0.05. So V1 0.05, that is 0.05 cubic meter over the displacement, which is actually calculated with respect to the area. What is the area? Area is equal to 0.25 meter square, and therefore we can say that the value for the the value for the displacement x becomes 0.2 meter, and therefore the force can be calculated as what? Kx, which becomes what? 150 kilonewton per meter times 0.2 meter, and that will give us what? 30 kilonewton. And we can say the pressure equals what? Force per unit area, which becomes what? 30 kilonewton over 0.25 meters square, and that becomes 120 kilopascal. So therefore the final pressure, final pressure is equal to what? Pressure at point 1 plus pressure at point 2. And what is pressure at point 1? I have 200 kilopascal. And what do I calculate now? This is point 2. 120 kilopascal. And I have the final pressure now to be equal to what? 320 kilopascal. We can determine B. We can go to B. What is B? So what is B? The work done. So work done is equal to what? Work done is equal to what? With these two sections can give us the work done. And that becomes what? Work done equal to what? Area at section 2 plus section 1. And that becomes what? Half sum. That work done can become what? Half sum of parallel side times height. So that we consider that to be a trapezium, and we call that work done to be the area under the trapezium, which is what? Half sum of parallel side times height. And what are the sides that are parallel? The sides that are parallel are this side is parallel to this side. So this height and this height are parallel. Half sum of this parallel side. And what is the height? This section is the height. So this is the height. And this 200 and 320 at this side of the parallel. So we cannot determine the work done. That's how work done is calculated. Is the area under this curve. So the work done. So B work done is equal to what? Half sum of parallel side times height. Remember, the height is what? The height is 0,05 and 0,1, and which is going to be their difference, which is what? Which is equal to 0.1 minus 0.05. This is equal to what? The height. And the parallel side is going to be what? 200 plus 320. These are the side of the para. So this is this side and this side. This is the height. That is the height. That is the para side. And this difference gives us the height. So these are the para side. This is the height. In that context, how do I write it? Work done is equal to what? Half sum of para side. I have what? I have 200 plus 320 plus 320. All that is supposed to be in kilopascal times the height. What is the height? 0.1 minus 0.05. And because I want to get a unit in standard unit, I'll multiply by 1 kilojoules over 1 kilopascal cubic meter, and that gave me a work done of what? 13. God bless you. Have a wonderful day. Thank you.